Hopefully, oh yep, that's working. Cool. Okay, here we go. So 4.8 linear inequalities. An inequality as opposed to an equality. An equality would be an equation. So, you know, y equals 3x would be an equation. Or even, you know, 2x plus 5 equals 7 would be an equation, or equals 7 plus 3x, whatever it may be. They're all just equations because they have an equal sign between them. An inequality is simply different because no longer is it an equation. It's saying that one side, in this case, is bigger than the other side. We've got, in this case, the right side is bigger than the left side. What it's essentially accounting for is that there's going to be certain values of x for which this will hold true, and certain values of x for which this won't. With an equation, there's only one value for x. Certainly in a linear equation, there's only one value for x for which the whole thing holds true. But in this, there's going to be multiple values for x. We'll get into that in a little bit. Firstly, just in terms of the symbols, inequality symbols, so this thing means less than, and we're reading them left to right. So the smaller side, less, and then this is obviously less than or equal to. And then greater than, again, reading it left to right, greater than, the greater part, the bigger part is on the left, and so that works. And then obviously greater than or equal to. And those are essentially, that's the terminology that you need for this part. No big deal. Linear inequalities. An equation is a statement of equality, such as x equals 17, a very simple equation. You have two sides being equal to each other. A linear inequality means that it's not equal, but it could be, depending on what the situation is, but rather it's a whole list of values that it could be greater than that. So, for example, x is greater than or equal to 17 means x can be any value greater than or equal to 17. So x could be 95, it could be 76. It can't be 15 because it's only greater than or equal to 17, and it can be 17. If it was just greater than 17, then it couldn't be 17, but it could be 17.1 or 17.001. Okay, cool. I'll probably have to try and turn those off somehow. I'm not sure if that was the... Anyway, who cares? So, for example, I've got some things there. On a number line, if I'm showing x is greater than or equal to 17, then I've got 17 here, and I can see that, here's the terminology, well, not the terminology, the technique. There's a coloured in dot. So that means that this is representing our values then, and effectively every value that holds true for this. So if x is greater than or equal to 17, then x can be any value along here, including 17, because it's a filled in dot. If it's just a non-filled in dot, like a small circle that doesn't have the dot filled in, then the number that it's above is not included in the possibilities. So yeah, now this is all numbers to infinity that are greater than or equal to 17 are possible solutions to this. The other thing is we can have an upper limit too. So for this example here, I've got negative 3 is less than or equal to x, which is less than or equal to 2. And so here my parameter is, again, I've got a coloured in dot here, and I've got a coloured in dot here, and this is saying that x can be any value between these 2 points. Any value at all, any real value. So it could be decimals, it can be you know, the square root of 1.5 or whatever it is. X can be any number in there, no matter what it is, as long as it's between those numbers and including those numbers. Now, the one below it, the difference being negative 3 is less than x is less than 2, there is no equals to. So the parameter is x can be any number in here, but not actually equal to negative 3, and it can't be equal to positive 2 either. So this is just a situation as opposed to when we're normally solving equations, you find one value, but now we're going to find a group of values, and this is how we're representing groups of values, essentially, with a number line or with an equation. So this is like the graphical representation, and this is the equation representation. So let's try the first worked example there. There all obviously can be combinations of less than or equal to and just less than. So here, x can be negative 3, but it can't be 2, but it can be anything between them. And on the example below, x can't be negative 3, but it can be 2, and obviously still anything between them. So now we're going to solve. Now, solving these equations is the exact same way that you normally solve normal equations, where you move things around from side to side, and yeah, solve and follow those rules. The only difference is that if we multiply -1 through the inequality, so multiply both sides by -1, then our inequality sign is going to flip, and we'll see an example of that shortly. But if I multiplied both of these, and it makes sense because this is not completing this example, but let's just have a look. If I multiply both sides by -1, then it would be -x minus 3, and I have to flip this, so it would be greater than or equal to -12. And depending on the value of x, that would hold true, but we'll see what we get on the end. Okay, so now we're not flipping it, we're not doing anything, we're just solving regularly. I've got x plus 3 on this side, and I've got 12 on this side. I want to get x on its own, as I always do. X needs to be alone. And we've got a plus 3, and we want to get rid of that. So how do we get rid of a positive 3? We subtract 3 from both sides, or if I move it to the other side, and it becomes -3. So I am going to end up with x is greater than or equal to, that's just staying the same, because I haven't multiplied anything by -1. So x is greater than or equal to 12 minus 3, and clearly x is greater than or equal to, what, 9. So that means then that any value of x greater than or equal to 9 will hold true in this inequality. So if I use 9, for example, well then 9 plus 3 is equal to 12, so that holds true. If I use the number 20, well 20 plus 3 is greater than or equal to 12. It's greater than, so it's just greater than. Without getting too complicated, I'm not going to do this as an example of the flip thing, but hello, sorry, you guys can hear everything now. It's just a meme, it's okay. So 4x minus 3, doing this next one, I've got 4x minus 3 equals -7. Alright, well that's okay, I can do the same thing. I want to get rid of this -3, so let's get rid of that. So I'm going to be left with 4x is less than, did I say less than before? I meant less than. Is less than -7, and it's plus 3, because I have a -3 here, moving over to this side becomes plus 3. Well, what's that? -7 plus 3 is going to be -4, and now I have 4x is less than -4. I need to get x on its own still, so I'm going to divide both sides by 4, and I will get x is less than -4 on 4, so therefore x is less than -1, because -4 divided by 4 is -1, because I have a negative divided by a positive. X equals -1, and I know that's fine. I can leave that there. I've solved it. I've got x by itself over here, and I have some numbers over here, or one single number in fact. Or rather the absence of a number, -1. Okay, so worked example 19. This is where something's going to happen, because I've clearly got a negative here, and I'm going to have to get rid of that. But let's just deal with it one part at a time. I feel like I'm going to do a mistake first. So let's start off by making it a mistake. No worries. Maybe if no, it doesn't matter. I'm going to have to remember to turn those off before I do this again. Yeah. I'm going to make a mistake. Let's assume I don't change this. So, I've got -4x divided by, -4x is less than or equal to 20. Well, let's move that around. Let's get rid of the -4. So, -4x less than or equal to 20, divide both sides by -4. -4. Well, -4 divided by -4 is 1, so I'm going to get x is less than, what's 20 divided by -4? I literally was waiting for a response just then, but I realized there is no one listening except me. 20, I've got positive divided by negative, so my answer is going to be negative, and 20 divided by 4 is 5. So -5. Okay, well let's test that. X is apparently less than or equal to -5. Well, if I plug this value in, let's pick x is, let's go -7, because -7 is less than -5, or less than or equal to -5. So I can try that. So if I go -4, -7 is less than or equal to 20. Well, -4 times -7 would be positive 28, and positive 28 is definitely not less than or equal to 20. So that's the key thing. That's the example there. Can we hold the notifications, please? I'm going to pause the video and fix that. Fixed it. Okay. Thank you, Mrs. Zuze. I helped Mrs. Zuze figure it out before, and then I couldn't remember how to turn them off. Okay, so I accidentally unplugged the microphone and then the thing refused to work again, so I've had to start a separate video. Hopefully these just two link in and you guys are none the wiser except for what I've just said. Okay, so effectively this is wrong, right? We know I need to flip this inequality. Now, if I had flipped it and it had been greater than or equal to, then, well, does that work? Or what's the number greater than or equal to -5? Okay. Sorry. Where were we? Oh, right. Okay. So what's a number greater than or equal to -5? Well, let's pick -3. That works. So if I replace this with a -3, and -3 times -4 is positive 12, well, look at that. 12 is less than or equal to 20, so that works. If you don't understand all that, and if that doesn't make sense, that's fine. Don't worry about it. The key point is, whenever you multiply both sides by any negative number, then when you're rearranging your equation, the equation has to flip. The inequality sign has to flip, left to right. So, -4x, we're doing it correctly now, -4x is less than or equal to 20. I want to divide both sides by -4 to get x on its own. So x, because -4x divided by 4, -4 is going to be x, is now greater than or equal to 20 over -4. This has changed from here to here because I've divided both sides by a negative number. If I times or divide both sides by any negative number, the inequality flips. That's literally the only difference between doing these and doing normal equation solving. Alright, x is greater than or equal to 20 divided by -4 is -5. So that means then that any value of x greater than or equal to -5 will be a solution for this inequality. Okay, try the same thing over here, except now I've got a number I want to get rid of first. So moving the 9 is currently positive, which means I need to subtract 9 from both sides, or effectively it comes over here and becomes -9. Then I would end up with 2x is greater than or equal to 5 minus 9. So that's clearly greater than or equal to -5 minus 9 is -4. So I've got -2x is greater than or equal to -4. I want to now get rid of this -2. So I'm going to divide both sides by -2. So -2x over -2 is, because now I've effectively done that division, I need to say then it's less than or equal to -4 divided by -2. Now that's going to be x is less than or equal to, -4 divided by -2 is positive 2. And any value of x that is less than or equal to 2 will be a solution for my original equation there. That appears to be it. That is this section in a nutshell. Hopefully I'll put all this together, upload that video, and if you have any questions, you're going to have to email them to me, and hopefully I can, I should be able to respond either to the email or in OneNote. I'll write a note on there to respond. Thank you very much.